In this example, we have a body resting on a horizontal surface, and we are given two coefficients of friction, the static value 0.33 and the kinetic value 0.25. The first step in solving the problem is to draw the free body diagram. And given that the force required to start the motion is horizontal, we can complete the diagram. This is the standard flow of the solution to most problems. We begin first by looking at the free body diagram and doing a summation of forces in a normal direction to get an expression for Rn, and then the value for the static friction using the expression F equals to mu Rn. And then finally, we do a summation of forces in the direction of motion. And in this case, okay, it's P, which works out to 16.19. So for part B, we want to find the kinetic friction force. Now note that the forces which are in the direction normal to the motion hasn't changed, so the normal reaction remains unchanged. And here we want to find the kinetic friction. So the coefficient of kinetic friction 0.25 applies. Okay, the kinetic friction works out to 12.26 newtons, okay, which is less, okay, than the static friction in part A. Okay. Now for part C, the force is applied at 60 degrees to the horizontal, okay, as shown. So friction acts to the left in the direction opposite to the impending motion. Now, the next step will be to resolve the force P, okay, into components, okay, along and normal to the direction of motion. And we next sum up the forces along the normal direction to get an expression for a normal reaction in terms of P. And note that Rn is no longer just equal to mg, because we have three forces involved in the direction normal to the motion. Now proceed to get an expression for the static friction. And finally, we sum up the forces along the direction of motion and substitute the static friction into that equation and solve for P, which works out to 20.6.